When you launch your EC2 instances, you can choose to put them in a placement group. And what happens is when you launch multiple EC2 instances, normally they'll just get placed on the underlying physical hardware in a way that you have no control over. So you don't really know if, let's say you launch two instances that are part of some kind of application cluster. You don't know whether they're sitting on the same underlying host, the same physical server, or whether they're spread across different servers. Now, because of application clustering, you might want to control that. You might also want to make sure that your instances are placed very close together so they have better node-to-node communication. So that's what placement groups are. Now there's three different types. We have cluster, partition, and spread. So with the cluster placement group, this is where your instances are placed very close together inside a single availability zone. And this means that you get really low latency, and node-to-node communication is low latency and fast because they're close together. So think about tightly coupled applications and think about high performance computing or HPC applications. I know in the SAA C02 version of the exam, high performance computing is starting to show up. Now at this stage, while I'm recording this, the beta has completed and the actual final release of the exam is scheduled for a couple of months' time because it's January 2020 at the moment. By the time you watch this, that may not be the case. You might already be studying for the SAA C02. And if so, make sure you understand high performance computing. And we'll talk a bit more about the different types of adapter that you use for high performance computing as well shortly. So we then have the partition placement group. And this is where your instances are spread using logical partitions so that you know that one group of instances does not share the same underlying hardware as another group. So you can have multiple instances on one host and multiple instances on another. Now I'll show you some diagrams shortly so that all this makes a bit more sense. We then have a spread placement group. And what this means is that you have your instances spread across distinct underlying hardware. Again, the diagrams will make this easier. So let's go through and have a look at some of these diagrams. So this is what a cluster placement group looks like. And you see that there's multiple EC2 instances within a single availability zone. And we know that these instances are going to be placed very close together, so on hardware that's very physically close. And that means that you get better inter-node communication. So good for high performance computing, good for tightly coupled applications, and good to make sure you have that low latency and good bandwidth between the instances. Now, you use enhanced networking, and that means you're going to use an enhanced network adapter or an ENA. So we then have a partition placement group. And here we can see that we can use multiple availability zones. And we have a partition here with a number of instances in it and another partition. And we know that these partitions are going to be located on separate AWS racks. So there's a layer of resiliency there because each rack has its own unique power sources and backup power sources. And obviously there's networking that's redundant as well. So you now know that you've got a cluster here which is in one rack, and you've got another cluster in another rack, and you've got another cluster of instances that's in another rack and another availability zone. And we then have the spread placement groups. And in this case, what you can see is each instance is actually located in a separate rack. So each of these red lines corresponds to a completely separate rack. So a rack, is a sort of closet that you put your servers into, and you have lots of different servers in them. And each rack is therefore going to only have one instance that's part of your application. So there's lots of resiliency there. You know that in this case, you have 5 EC2 instances that are part of your application. And you know they're spread across 5 different racks. And each of those racks has its own redundant power and networking. So lots of resiliency for your application. We're in the AWS Management Console, and I'm just going to head over to EC2. And you may notice that as this is a newer video, the look and feel of the EC2 console is changed a bit. So we can see up here I'm actually using the new EC2 experience, and you can easily switch that off if you want to. It's not a huge difference, but there's just a few enhancements. Now we're just going to scroll down to placement groups under networking and security. And what we can do now is we can go in and create a placement group. And so I'm going to create my cluster PG for placement group, and I'm just going to choose the strategy cluster, and we can choose create. And then we can go back in and we can create a spread. And I'm going to call that my spread PG. And let's just go in and also create a partition placement group. And this is the only time that you need to specify the number of partitions. Let's just choose 2. And it says the maximum number is 7. So we've created all of those, and that's really all there is to it. And what we can do now is go to instances and launch an instance. Now what I'm going to do first, I'm just going to carry on as per normal and choose the Linux 2 AMI and the T2 micro. And we can see here that we can choose to place the instance into a placement group. So let's have a look. Let's add to an existing placement group. And what we can see is I can add these into a my partition placement group, and I can add into the spread partition placement group that we created. But as you can note, there's no cluster placement group here, and that's because the T2 micro cannot go into a cluster placement group. So there are specific requirements on what instance type you can add. So let's just cancel out and try again. I'm still going to choose the Linux 2 AMI, but let's go down and try a C5 large. Choose next, choose to add to a placement group. And now we can choose to put it into the cluster placement group as well. And we're not actually going to go and launch any instances now. I just wanted to show you where you go to create your placement groups and then how you can actually specify the placement groups when you launch your instances. So when you add to a placement group, EC2 will then automatically ensure that the policy for that placement group and how your instances are placed on the hardware is followed. Now let's just go back to the slides, and I've got one more here for you. And this just compares the different types of placement groups. So we've got the clustered, the spread, and the partition. So with clustered, this is about placing your instances into low latency groups within a single AZ. And you use it to get low network latency and high network throughput. And remember, you can use an enhanced networking adapter with your clustered placement group. It's recommended that you do launch all your instances up front, though you can add them later on. With a spread placement group, your instances are spread across underlying hardware. And this reduces the risk of simultaneous instance failure if the underlying hardware fails. And that can also span across availability zones. You can have a maximum of 7 instances running in a spread placement group per availability zone. We then have the partition placement group. And in this case, the instances are grouped into logical segments called partitions, and they each use distinct hardware. And you use that to control visibility into your instance placement. We then have the partition placement group, and in this case, the instances are grouped into logical segments called partitions, and they use distinct hardware. So you can control the visibility into your instance placement. This reduces the likelihood of correlated failures. So, if multiple racks go down in AWS, then you can ensure that your application stays running because you've spread your application across lots of different racks and lots of different underlying hardware. So that's it for placement groups. Now, in the exam cram at the end of the section, I'm going to talk a bit more about the different adapters that you can use with high performance computing and also for enhanced networking. So the elastic network interface, the standard type of adapter, the enhanced networking adapter, the ENA, and also the elastic fabric adapter.